Dr. B.K. Singh from Ajay Kumar Garg Engineering College, Ghaziabad. So, this is the 6th lecture of Unit 1. In previous lectures, I have discussed about the cement, one of the important ingredients of manufacturing of process of concrete. So, second important ingredient is aggregate. So, aggregate is very important because aggregate constitutes about 65 to 75% of the total volume of the aggregates. So, what is of the concrete? So, what is the aggregate? So, aggregate is nothing but aggregation of solid particles other than paste is called aggregate, and it must be inert and inexpensive. Inert means it should not have a chemical reaction. So, once chemical reaction if it had, then there will be some problem, some expansion in concrete will take place in longer time. So, that is very important. So, since large volume, if you see this diagram here, so here concrete constitutes of cement, coarse aggregate, fine aggregate, coarse aggregate, fine aggregate, water, admixture, and some air will be there. So, always some air will be there of some 1-2%. Okay. So, if you see here this diagram, so coarse aggregate and fine aggregate, this is the major part, this is the major portion of the concrete, almost 65 to 75%, and cement will be around 10%, depends on the grade of concrete, this will vary, but approximately you can say it is a 10%, water will be 20%, not by weight, it is by volume. Okay. This is by volume, and we add some admixture also. So, admixture and air you can say about 5%. So, totally we have about 65 to 75% total volume. So, its impact is very important. Okay. So, if you consider the impact, because characteristic of aggregate is influencing the characteristic of concrete also. So, if you see here the classification of aggregates. So, from basis of size we have two types of aggregate, fine aggregate and coarse aggregate. So, that has been discussed at the introduction lecture. So, fine aggregate is nothing but if you have 0.075 mm to 4.75 mm. So, this is the size of aggregate, means 75 micron meter to 4.75 meter particle is considered fine aggregate, and coarse aggregate is 4.75 mm to 80 mm. So, this is the ISO classification. So, this particle size is very important. So, main idea is we should have all the types of particle available in the concrete ranging from 0.075 mm to 80 mm. So, less than 0.075, less than 75 micron meter will be sealed and clay. So, this is a harmful constituent. So, we have to see that it should be within the permissible limit, their percentage should be very low. Now, you can see here on the basis of geological origin we can say natural aggregate. So, natural aggregate means we can get from the rocks. We have three types of rock: igneous rock, sedimentary rock and metamorphic rock. So, igneous rock from where we get? So, suppose we have a mantle in the earth from mantle volcano will take place, and during the volcano, suppose you have a mantle here, this is a crust, this is your earth crust. So, crust, then we have mantle, then we have inner core, outer core and inner core. So, crust is about 200 kilometers, okay, depth of crust. So, mantle here magma will stay, in mantle magma will be there, that is in liquid form, but whenever volcano is taking place due to the spreading of the crust at a boundary level. So, here say let us say volcano is taking place. So, as this is getting cooled down slowly, then the rock formed will be called igneous rock. So, like granite, dolerite, basalt, etc., is the igneous rock. So, that is going to give you a very good quality of aggregate. Similarly, we have sedimentary rock. So, due to the sedimentation of either igneous rock or metamorphic rock, we can get the stone, that is a rock, that is called sedimentary rock. So, for we can use sandstone, limestone, etc., can be used as a natural aggregate. And then we have metamorphic rock. So, metamorphic rock is produced under the heat and temperature and pressure on igneous rock or sedimentary rock. So, like example is gneiss is there, quartzite is there, marble is, etc. So, these are the important classification of natural aggregate based on geological origin. Okay. Geological origin. Geological origin. So, we have granite is there. So, this is a very hard rock, and all the types of granite can be used as a aggregate. So, this is very important. Then we have availability. So, what are the things? This is available in the form of gravel form. So, gravel form you can get from the stream bed gravel, river traces gravels, floodplain gravels, beach gravels or glacial gravels. So, these gravels is also a natural aggregate, but we have not to break it. This is naturally available due to the weathering action or some mechanical work done on this rock. So, directly the gravel which we are getting from the stream bed, directly you can use if silt is not there. If silt is there, then you have to wash and do it. Similarly, river, there is a courses change of course of the river due to the geological region, geological time, due to meandering and all that. So, there also you can find lots of gravel, sand particle there. So, that you can use, but that may be mixed with some silt or clay. So, if it is mixed with silt or clay, that case you have to wash it. Similarly, in floodplain gravels. So, if it is a floodplain, there also stream you will carry the gravels. So, from there also you can collect. Similarly, sea beaches you can get the gravels. So, that also can be used, and glacial gravels. So, due to the change in the temperature like freezing and thawing, breaking of the stone will take place, and that rocks can be used as a aggregate. So, these are the source of natural aggregate. Similarly, we have the artificial aggregate. So, artificial aggregate means you can take blast furnace slag, you can crush the slag and you can get your desired site. Similarly, you can use the broken bricks. So, like this you can use as a artificial aggregate. Similarly, on the basis of a specific gravity, also we can classify the aggregate. So, depends on the requirement of the aggregate concrete. So, concrete we may have three types of concrete. Basically, we can say we have normal concrete, we have normal concrete, we have lightweight concrete and we have high density concrete. High density concrete. So, suppose you want to produce the normal concrete. So, normal concrete density will be around 2 to 22 kilonewton per meter cube to about 24 kilonewton per meter cube. So, if you want to produce this type of concrete for general purpose, general use, so you have to use those type of aggregate, like if you are using the granite, dolerite, basalt, gneiss, quartzite, sandstone, limestone, quartzite, etc., you can obtain a normal weight aggregate. And with the normal weight aggregate, the density of the aggregate will be around 22, means 2200 to 2400 kg per meter cube if you are measuring the. Similarly, if you want a lightweight concrete, so their density may be ranging about 3 kilonewton per meter cube to say about 18 kilonewton per meter cube. So, this may be called a lightweight concrete. So, that is required for some special purpose. So, for that you have to use certain special type of aggregate. So, that you can use shale, clay, slate, crushed slag, pumice, scoria, perlite, diatomite, sintered fly ash. So, all these things can be used. So, based on the specific gravity, because that will be having a lower value of a specific gravity, that can be considered. Similarly, you want a heavy weight aggregate for producing the high density concrete. So, where high density concrete is used? So, generally in nuclear power station. So, for dome structure. So, that radiation will not take place, there we are using high density concrete, or in hospitals where you are say you want to do the X-ray test. So, that X-ray test, so radiation should not cross through the wall. So, sufficient number of sufficient thickness of wall should be there, and that should be having a dense aggregate you have to use. So, in that case you can use barite, limonite, magnetite, hematite, iron barite, or even iron pieces. Okay. Iron and barite you can use as a heavy weight aggregate. So, on the basis of a specific gravity, we have 3 types of aggregate. Similarly, on the basis of shape, round shape, cubical shape, angular shape, elongated and flaky aggregate. So, this is very important, and these stones, how rocks is made? Rocks is made of minerals, different types of minerals. So, out of that, if you have a quartzite, suppose we have quartzite, silica oxide is there, okay, in free form. So, this mineral is very important. So, if aggregate is having SiO2, so that type of rock will have very good quality of engineering properties. They are very hard, okay, and density is also good. So, we have to use the mineral, but quality of aggregate will depends on the mineral character. Okay. So, mineral character is important, but once you consider the shape, so shape is independent of mineralogy. Whatever the mineral is there, even is a good quality of rock, but if their shape is not proper, suppose you have a elongated and flaky shape, which length is very more. So, with respect to the cross sectional dimension, or it is a flaky in nature. So, that type of, even if you have a very good quality of petrology, good quality of rock, geology point of view, but their shape is not good. So, that is not going to give you the good quality of concrete. So, for getting the good quality of concrete, you should have angular aggregate like this. This is angular shape. Okay. this is a angular aggregate, and this you can say this is elongated, this is having elongated shape, okay, and this is having the elongated shape. So, elongated shape, I will just remove this portion so that, okay. So, elongated shape is important here because if you are using this type of aggregate, it is not going to take you the load and lots of void will be there, and finally, weak quality of aggregate, their strength will be very bad you can get. If it is a rounded one, so rounded one will give also some another advantage, it have better workability, you can easily mix it, compact it and place it properly. Okay. So, water demand will be less in this case, but bond strength of this rock will not be bond strength of this rock will be smaller with respect to the angular one. So, suppose you want to produce very good quality high strength concrete, that means you should have angular type of aggregate, aggregate crushed stone. So, that you can get from the crushing of the stone. Okay. So, we have just I told you, have a gravel or a stone that is had to be crushed of different size, and after the crushing you have to grade it. Okay. So, this is very important, angular type. So, that is going to give you better strength, better bond. So, we do not have proper experimentation how to measure the bond strength of cement paste and aggregate, but bond is very important. Interface of aggregate and cement, if it is not having a proper bond, then there will be reduction in the strength of the concrete. Okay. So, on the basis of texture, we have a smooth, granular, crystalline, honeycombed and porous type of texture. So, this is also very important. So, this texture you have to consider. Okay. So, now we will discuss the properties of aggregate. There we have a very important thing is the fineness modulus. So, fineness modulus is nothing but it is an empirical number obtained by adding the total percentage of the sample of an aggregate retained on the each of a specified series of sieves and dividing the cumulative sum by 100. It represents mean size of the aggregate. So, okay. So, what do you understand by different type of sieve sets? Okay. A specified sieve size. So, sieve size means you have to consider like this. So, we have a sieve size of say 80 mm, 63 mm, 40 mm, 20 mm, 16 mm, 12.5 mm, 10 mm, 4.75 mm, 2.36 mm. So, this is for coarse aggregate, and for fine aggregate once again we have this range 10 mm, 4.75, 2.36, 1.18, 600 micron meter, 300 micron meter and 150 micron meter. So, you have to go for the sieving. So, you have to sieve through this sieve. So, sieve means we have to consider, because this is not having a exact shape, whatever the shape you say, different type of shape we have. Okay. So, like this aperture we have to consider a square. So, a square aperture we are considering. So, whatever the sieve is there, that is having a square mesh. So, that if you are doing the sieve analysis, So, this particle, if a smaller particle pass through this aperture and the size bigger than that square will retain on the particular sieve. So, we have to arrange this sieve in a order, increasing order, okay, according to the size, and last we have the pan. So, you have to keep in sieve shaker. This is a machine, either you can do by hand sieving or by mechanical sieving. Okay. Either you have to do by hand sieving or mechanical sieving. So, in that case what you have to do, you have to arrange this, and then you have to sieve. After the sieving, this particle will retain on that. So, you have to calculate the percentage. So, like this, suppose you want to do the fineness modulus of a fine aggregate or all in aggregate or coarse aggregate, you have to sieve it and you see the cumulative retained material, what is the percentage retained. So, say 10%, 20%, 100%. So, add all that and divide by 100. So, you divide by 100, then that number you will get. So, those number is called fineness modulus. So, if you have a higher value of fineness modulus, that is going to result with harsh concrete. You are not going to get the concrete will be harsh in nature. So, that voids will be more. If you have a lower value of fineness modulus, so void surface area will be more, surface area will be more. So, surface area will be more. So, that will lead to uneconomical design, because in that case we have to put more amount of paste. But suppose you want to produce a very good quality of concrete or high strength concrete. So, in that case we need more finer particle. Okay. So, similarly, we have fine sand, means fineness modulus is ranging between 2.3 to 2.6, medium sand value range from 2.6 to 2.9, and coarse sand values range from 2.9 to 3.2. So, say I want to find out I want to find out fineness modulus of coarse aggregate. So, coarse aggregate means it is going to retain on say 4.5. I will just go to the this slide. So, this is going to retain on this 1, 2, 3, 4 and 5. Okay. So, 100% material is going to retain on this sieve, because coarse aggregate is ranging from 4.75 to 80 mm, 4.75 mm to 80 mm. So, this is certainly going to retain on this 5 sieve. So, whenever you are considering the fineness modulus of coarse aggregate, so in that case whatever the material is retained, percentage retained, okay, on the sieve above 4.75, 10 mm and others, divided by plus you add 500, because 100% material is going to retain on 2.36, 1.18, 600, 300, 150 micron. Okay. So, we plus add 500 and then divide by number 100. So, if you, then you will get the proper value of this material. Okay. Proper value of fineness modulus of aggregate, coarse aggregate. Okay. That care we have to take. So, this is very, very important. So, if you see, so based on sieve analysis, we have to go for the zoning, grading zone 1, grading zone 2, grading zone 3 and grading zone 4. So, if your material is, say, you see, you just go and sieve. If you are getting a material 100% passing, about 10% 90 to 100 will be there percentage passing, here 60 to 95%. So, if you are getting in this range, then you can say it is a grade zone 1. Similarly, you are getting a zone 2. So, in that case also you will get this type of retained conditions. So, as you move from zone 1, 2, 3 to 4 side, their fineness will going on increasing. Okay. So, suppose you want to do for the RCC work. So, if it is very very fine, so this type of grading you have to check before using. Okay. And in this table, a 5% variation, maybe because some of the particle you are not able to get here. So, 5% variation you have to consider here. For crushed stone sands, the dismissible limit on 150 micron IS sieve is increased to 20%. This does not affect the 5% allowance permitted in 4.3 applying to other sieve sizes. So, that you have to consider, and first for suppose you want to make aggregate concrete mix. So, this grading is very very important, this data is important. So, similarly, if considering the coarse aggregate, so coarse aggregate, this is for single particle. Say you want to have a maximum size of aggregate 63 mm or maximum size of aggregate is 40 mm. So, like that, if you have a single size of the aggregate, so this is the range you have to consider here. Okay. So, similarly, if you considering the all in aggregate, passing for graded aggregate for nominal size 40 mm, 20 mm, 60 mm, 12.5 mm. So, in that case, this is the limit they have given for the 40 mm. If you have a 80 mm maximum size of aggregate, so based on that 20 mm maximum size of aggregate, this is the limit. 16 mm maximum size of the this is the limit, and 12.5 this is the limit. So, sometimes what we have to get, either you can get all in aggregate or graded aggregate, or sometimes you will get a in a different size 20 mm downside, 12.5 mm downside, and you have to mix some percentage based on the properties. So, so ratio you can say 40% I am going to mix 12.5 size aggregate, and 20 mm downside I am taking the 60%. So, like this by trial and error, say 50% is also possible. So, different ratio you have to go for the trial based on the thing, so that you can get the maximum density. So, this concrete is there, so, in concrete what are the things is there? We have coarse aggregate, and this void is filled with fine aggregates. Okay. And this fine aggregates is finally filled with paste. Okay. So, if you have a proper density packing, then in that case you will obtain a very good quality of concrete. Okay. And that will be economical. So, this is for mass concrete. So, mass concrete we using large size, even 80 mm size aggregate. So, here they have given the classification for if you are using for mass concrete. So, you have to refer, this table has been directly reproduced from IS 383 1970. So, similarly, this is the grading curve. So, this is very very important. This is the standard grading curve, all in all aggregate curve. So, here size we have written different size, if it is a fine, medium, coarse and gravel. So, these are the different type of sizes you have to consider. This curve is very very important while we do the mixed design. Then we will discuss this in large. So, we have a types of grading. We have informed grading, continuous grading, gap grading. Informed grading means we have a same size of aggregate. Similarly, continuous grading means we have all the types of particles. So, that is a preferred, this is a preferred, and we have a gap grading. So, gap grading, some of the particle or one particle is missing. So, this can be used for architectural purpose, ornamental purpose, but not normal. So, generally we are using the continuous grading gradation of the aggregate. Okay. So, thank you.